All right, we're on the back side of day 3 notes, and in number 3, it says given triangle bag. So B is at -2, +1. Put a dot, call it B. A is at -9, so 2, 3, 4, 5, 6, 7, 8, 9, +6. 1, 2, 3, 4, 5, 6. Put a dot, call it A. G is at -5. 1, 2, 3, 4, 5, +10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way at the top. Okay. Try to use a straight edge to connect. Okay. And then we did part A. So part B says on the same set of axes, graph and state the coordinates of triangle B prime, A prime, G prime, the image of triangle bag reflected over the line y equals x. Okay. Well, y equals x, remember in the warm up, was that diagonal line. So it starts at the origin and goes up 1 over 1. This one's really important that you use a straight edge. Okay. But I'm going to do my best to draw my dots and use a nice straight line. I can't find my straight edge tool on here. But because I graphed every point there, that should give me a nice line. All right. So that red line is y equals x, and that's what we're going to go ahead and flip it over. So how do we do that? Well, because the line is diagonal, we have to count diagonal to it in order to be perpendicular to it. So if I'm at B, I'm going to count diagonals. So this is what I consider one diagonal block. And do you see this next one? That's what I consider a half a diagonal block. Okay. So I basically are saying there's 1.5 diagonal blocks to the line. So I have to go 1.5 diagonal blocks over the line. And it's going to be right here. Okay. And we're going to call this B prime. Okay. All right. Let's see if A is any easier. All right. So A, I'm going to count diagonal blocks. 1, 2, 3, 4, 5, 6, 7.5. So 7.5 to the line. I have to go 7.5 over the line. So there's my half. 1, 2, 3, 4, 5, 6, 7. So right there. So this is A prime. That's the reflection of A over that diagonal line. Notice I'm counting diagonals, so those green line segments are perpendicular to my red line, and that's what they have to be for a line reflection, okay? We got one more letter to reflect over, and that's G. So here we go. 1, 2, 3, 4, 5, 6, 7.5. We 7.5 also. So there's the half. 1, 2, 3, 4, 5, 6, 7. And that is G prime. Nice straight edge to connect my points. Oops. And there is my reflected triangle, okay? So now all I have to do is state its coordinates. And so looking at B prime, looks like, remember to go back to the origin and count, and that's +1, -2. +1, -2. And what a lot of people do is they look up at the original and they say, hey, all I'm doing right now is flipping them, right? You see that? So if I look at A's coordinates, let's see if that holds true. Okay, back to the origin. So we would count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. So +6, -9. Okay. And you can see that that rule is going to hold true with what we thought in the first one. You're just taking the two coordinates and you're flipping them. Okay, so the last one should also hold true for that. So G prime is at +10. 1, 2, 3, 4, 5. 5 down. So +10, -5. And again, you could see that that property holds true. There's 10, -5. Okay? It was originally -5, 10. So write a mapping rule. So the mapping rule, hopefully we just talked about. Okay? All you have to do is take your coordinates. If you're reflecting over the line y equals x, y comes first, x comes second, and it's finished. Okay. All right, we got a text box here that talks about properties of transformations, and they want to know, are the following properties preserved in a line reflection? Okay, check all that reply. So they're asking about distance. Is the distance between 2 points the same in the image as it was in the pre-image? So for instance, let me move back up. Let's take a look at side AG. I'll highlight it. Okay. Here's side AG. Here's side A prime G prime. Is the distance between A and G the same as the distance between A prime and G prime? Yeah, the side of that triangle will remain the same. So yes, distance is preserved. Okay. Angle preserving. Let's say we measured angle G, and let's say we found, I don't know, to be 62 degrees in it. Well, if we measure angle G prime, would there be more, less, or the same number of degrees in angle G prime? And hopefully you say the same, which means angles were preserved. Okay. Next is something we haven't heard before. It's called rigid motion. Okay. It says, did the transformations preserve distance and angle measure? Okay. Did it preserve both of them? Yes. Therefore, a line reflection is what they call a rigid motion. Okay, you're doing a motion by flipping, but the triangle is what they call staying rigid. Okay, like a dead body stays rigid, right? It doesn't really change. Okay, however your hands were when you die is kind of the same as they are hours later. They're rigid. Okay. And so the triangle stays rigid, but you're doing a motion, so they call it a rigid motion. Okay. All right, next up, we got a little thought bubble here talking about something that you probably talked about in algebra called Hoy-Vooks. Hoy and Vooks are just three little, I wouldn't call them words, like an acronym to remember some stuff. So Hoy is for horizontal lines. They are to remind you that they have zero slope, okay, because they're not going up, they're not going down. And the equation of a horizontal line begins with y equals, and then all you have to do is fill in the number. Okay? So if I asked my calculator to graph y equals 8, it would graph me a horizontal line. If I asked my calculator to graph y equals 5, it would graph me a horizontal line. If I asked my calculator to graph me y equals -7, it would graph me a horizontal line. Okay? Whereas vertical, or Vooks is to remember vertical lines. Vertical lines have undefined slope. Okay? They go straight up and down. Okay? Their equations are x equals a number. So for instance, if I were to graph, x equals 2. However, we can't do this in our calculator because we don't have an x equals button, but x equals 2 would graph me a vertical line at 2. Okay? If I asked my calculator if I could to graph x equals -10, it would graph me a vertical line at -10. Okay? But again, we don't have an x equals button. So you're going to have to remember that y equals a number, okay? Horizontal lines that go left and right, okay? And x equals our vertical lines. All right, so number 4, it says given triangle cat with vertices at 0, 0 for C, 2, 8, 3, 4, 5, 6, 7, 8 for A, and then -4, +5 for T. Okay, we'll draw, if you can, use a straight edge. Okay. And part A is finished. We graph triangle cat. Part B says on the same set of axes, graph and state the coordinates of triangle C prime, A prime, T prime, the image of triangle cat reflected over the line x equals 3. So as soon as I see x equals a number, I'm thinking of Vooks. Okay, it's going to be a vertical line, and remember, vertical lines go up and down. So I'm going to hold my straight edge vertically up and down and graph it at +3. So 1, 2, 3. And here comes x equals 3. All right, and that becomes our line of reflection. Okay, so we're going to go ahead and take our triangle and flip it over. So we'll do C first. C was 3 units away from the line of reflection, so 3 units on the other side would put C prime here. Okay, A is actually only 1 unit away, so he only has to go 1 unit on the other side, become A prime. And T is 1, 2, 3, 4, 5, 6, 7 to the line. 1, 2, 3, 4, 5, 6, 7 over the line. And that becomes T prime. And then we'll go ahead and try to use nice straight lines. And there's our triangle. Okay. C prime is now located at, remember, always go back to the origin to count. 1, 2, 3, 4, 5, 6, 0. A prime is at, always go back to the origin. Okay. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 4, 8. Okay. And then T prime. Again, go back to the origin to start counting, and that's going to be all the way out. That's 10. 1, 2, 3, 4, 5. 10, 5. All right, and there's no rule for that one when you reflect over a line that's not y equals x or an axis or the y-axis or the x-axis. But here are some of our rules to make things a little bit easier down here at the bottom. Okay. When you reflect over the x-axis, remember you change the y. Okay. Remember when you reflect in the y-axis, you change the x. Okay. Remember when you reflect over the line y equals x, it changes the coordinates. So y comes first and x comes second. Okay. And we didn't do this one, and you don't see it a whole lot. It's very rare in our course. But if you reflect over y equals negative x, it negates the coordinates and switches them. So it'd be negative y, negative x. I wouldn't focus on that one so much as I would focus on these ones. Okay, knowing the rule is helpful, but you don't have to know the rule because you can always figure out the rule from graphing it. All right, so hopefully that helps. And I'll see you guys on the next day of notes.